Howdy. Looks like we've got decent sound today, not terrible. But I'm looking through the practice quizzes, getting ready for this exam coming up. And so I thought I'd look at some of these and pay a little attention to the answers here. So I'm going to start off with breaking my computer, apparently. And there we go. So I've got looking for the IMFs, and so keep in mind ionic is first, then hydrogen bonding, then you have dipole, and then we're going to look for London dispersion. So ionic, they need to cross the staircase. Remember, H goes above the B and the C. Hydrogen bonding, we're looking for a hydrogen on an oxygen, nitrogen, and a fluorine. And dipole, we just need an oxygen, nitrogen. We need a heteroatom, basically. We need oxygen, nitrogen, chlorine, bromine. We also would like to have a separation of charges. So a place we can draw a line and get all the positives on one side. And so when it says dipole, it's talking about a plus and a minus. Everything has London dispersion, so that's kind of our default. Anything that's mostly carbon and hydrogen, if it's all carbon and hydrogen, it's all London dispersion. So argon is strictly going to have London dispersion. Hydrochloric acid. So here I've got, it looks like a little bit of hydrogen bonding, but it's really the dipole way worried about. HF, we have a little bit of hydrogen bonding. Calcium chloride, it's ionic. And then CH4, that's methane, or carbon tetrahydride. And it is all London dispersion. Okay, so pay attention to these. The OH indicates this is going to have hydrogen bonding. And this one has hydrogen bonding. Okay. Greater forces, if all things are the same, you can go by the amounts of things for hydrogen bonding. And we can also go by the amounts of carbon. So this one has dipole. This one has hydrogen bonding, whereas these do not. Up here I'm looking at the difference in mass will affect this. Okay. Rationalize these, and so HF versus HCl. Notice HCl is negative, HF is higher. That's the effect of hydrogen bonding. This in A, the effect was caused by dipole. And then here I've got, if I count the carbons, I see I have more carbons here, and so that's a stronger London dispersion process. All right, highest boiling point. So anytime we're looking at highest boiling point, we're going to be looking for our ionic first. If not, we go hydrogen bonding. If not, we go dipole. So I'm going to go dipole. Highest freezing point. All right, and so again on this one, freezing point and melting point are the same, and so we're going to be looking at our water, which gives us 2 hydrogen bonding. We got salt, which is going to be our ionic compound, and then hydrogen fluoride gives us 1 hydrogen bond. So ionic compounds, salt will be our winner. Lowest vapor pressure. All right, so the stronger the IMF, the lower the vapor pressure, and so we're going to be looking for the biggest Cl2, Br2, I2. We're looking for the biggest mass. Lowest freezing point. So we're going to be looking at the strongest IMF. Highest boiling point, same kind of deal. So HF has hydrogen bonding. This one, 1 carbon, 2 carbons, or 3 carbons. 3 carbons should be the highest melting point, and so the lowest will be CH4. Let's be careful about whether it's lowest or highest. Excellent. Thank you. Okay, we're ready to move on to practice quiz 2. So this is based off a unit cell. So we've got simple cubic, which only has things on the corners, and so that would be each corner is 1/8 of an atom. So that would be one atom, because there's 8 corners. We have, in this case, the one we see here is BCC, so there's one centered in the middle, so I have 1/8 for each corner and 1 for the middle. So in this particular one, my compound would be Cl and Cs, and it's going to be a 1 to 1. Alright, and then we also have FCC, where I would have each face instead of the body, and each one of these gives me half an atom, and so there were 6 faces, so that'd be 3 atoms there, plus 1 for each corner, being 1/8, and that would give me 4 total atoms. So SC, the distance here would be 2R. FCC, we can do Pythagorean theorem, and we end up with the distance from one corner to another corner is being 4R, where R is the radius. And so the side becomes the square root of 8 times R. And then BCC takes a little more work. You have to go from one corner to the next corner. And so that actually you have to use Pythagorean theorem twice. We're not going to worry about that, so we will only be asking you simple cubic and FCC. So this one, they said we've got FCC, X-ray diffraction. They gave me the length. And so what I'm going to do is use that length to find, that's my edge length, that's A. All right, and so I can use that to find the radius, and that's what they asked for there. They also gave me the density, and because it's FCC, I know it's 4 atoms, and so I could figure out the grams per mole. That'll give me the molar mass. And so let's go ahead and start those. So here's my 4R going across. This would be 4 radiuses, so a circle here in the middle. Alright, so first thing I did is I converted the picometers to centimeters, and then I'm going to cube that. So I went ahead and did that set up here, and I got 6.024 times 10 to the negative 23rd cubic centimeter. And then I went ahead and did the grams times, the density times my cubic centimeter, and that gave me the overall mass of my unit cell. So it's a real small number, which is what we expect. And each unit cell has 4 atoms, so I went ahead and converted that over to moles. Then I figured out the grams per mole, and that was platinum, which when I pull up a periodic table, platinum here is at 195, and so that's pretty good. Alright, number 3, it told me the radius and the density, and they want to know if it's BCC or FCC. Since I don't know how to do BCC, I'm just going to go ahead and do the FCC. I don't want to memorize how to do BCC, and so I took this radius of is 144 and went ahead and converted that into centimeter, and then I'd use that radius to find the length of each side. Then I cubed that, and that gave me the volume. So this is the volume of my unit cell. And it contains 4 atoms. And since I know it's gold, it's 197 grams per mole. And so I've got the mass of it, and I can just use the density and divide these the density by the mass divided by the volume, and find the density. And I got 19.37, which was close enough. There are some rounding errors in there. So I'll call that FCC, and so that'll be my answer to the other 3. All right. Thank you.